These are the aluminum blocks that I'm using to mount my elevator bell crank. And there's a small issue here. I'm going to see if I can get this on film, at least get it in focus. This upright, well, let me back up a little bit. The longerons, they start to curve inward toward the tail to make to come together at the tail. So these are curved. And when you put these uprights in order to have this face of the upright even with this face of the longeron, this ends up being, let me see if I can do this. This ends up being angled like this because of the curve of the longeron. So what happens is with these blocks, I don't know how well this is going to come out, but the block is actually angled in like this on this side and on the other side here. So what I need to do, let me see if I can get this again. These blocks are actually angled in like that because of this being at an angle. So what I need to do is these blocks have to be brought out like this. So what I need to do is I need to make up a little wedge to put underneath here the length of the block, so it will take it from here to here so that the bar of the elevator bell crank will run straight across this way and it won't bind. So that's what I've been working on. I've got the wedges made. I'm going to take a picture of them and then I'll cut them to size. Here's the piece that I beveled on the edge. This beveled area here, this is going to be what gets stuck underneath the mounting blocks for the elevator bell crank. I don't know if this will come out or not, but it is beveled. It's cut at an angle, or it's sanded at an angle. I had just used this on my belt sander. I just ran it, if you can imagine the belt sander vertical. This just got ran back and forth across it to give me this angle here. No real science behind it. I'm hoping this will be close enough anyway that when this is underneath the blocks, it will get those blocks parallel to one another, so when the bell crank bar is put in between them, it won't bind. It will be able to turn nice. So what I'll do now is I'm just going to cut these to length and then put the holes in them and see how it fits. Here is my version of the elevator bell crank. Now, the one thing that probably stands out the most are these two tangs here that make up this fork. And the reason I have that on there is because, let me grab one here. Come here. I am going to be using a push-pull tube coming right off of the stick, and this rod end goes right in here like this. So that is the reason for the fork. One thing that you may have noticed is that this piece here is started off as a piece of round tubing. It is not the airfoil shaped tubing, the streamlined tubing. It's just a standard piece of round tubing. It is, I believe it's 1 1/8 inches in diameter. This piece here is 3/4 of an inch. This tubing is 3/4 of an inch from the print. And you want something, this tubing here needs to be big enough to be able to take a 3/4 of an inch hole down through the middle of it. And you want a decent amount of meat on either side of that so you have something to weld to. So this piece, I'm positive it's 1 1/8 inches, so it's 3/4 inch and 1 1/8 inches. The other thing is, let me grab another one. Hold on, I gotta grab something else. I'm gonna zoom out here a little bit. Come here. Okay. This is not the proper size, but I am going to be making my cables with these swage on fittings. And this particular one here is for this one is for 1/16 of an inch cable, so this is not the proper size. The cables, the control cables are going to be 3/32 of an inch. So the fork for the 3/32 cable is going to be bigger than this one. But since I'm using a fork, I did some research and was able to nail down the, let me see if this will stay somewhat in focus, the slit that is in between these tangs of the fork, if you will, that opening where your fitting fits into, that distance on a 3/32 inch fork swage-on fitting is 0.108. So what I had done was I bought my 1 1/8 tubing, and I bought it 49 wall thickness. So now when I pinch this, when I crimp the end, I get roughly, what is that, 0.098 thickness. And that thickness, the 0.098, will fit really nice inside of the 0.108 swage-on fork. So that's why I went with the 049 wall, because the math just worked out good enough that when it's pinched, that fork will fit on there nice. I don't have to worry about spacers or washers or anything like that. There was some debate I had heard about as far as doing the pinching of the tubing, and it made sense to me to go ahead and heat it and pinch it. I just put it in a vise. I don't know how well you can see. But I had rounded the edge of the angle pieces that I put in the vise, so that this transition from the flat back out to this curved part, that would be a nice rounded transition. You don't want a hard 90-degree piece of angle in your vise, because it will leave a definite hard crease through here, and this is a little bit more rounded. What else did I do? You may have noticed that I went ahead after I did the pinch and I used a caliper on this to make sure that it was thin enough to fit inside of the fork. I went ahead and welded it shut. Not necessary, but it's just something I wanted to do to make this edge nice and clean. And of course, to adapt my fork end, or my rod end, I went ahead and made up the fork and welded it on as well. So if you can imagine, that's roughly how it gets set up in the plane. This will be my push-pull tube here, and then a cable coming off here, and a cable coming off here. Since this is a push-pull tube, it works in both directions, so there's no need for any hole or cable on this side. The other thing that I did, and this is kind of a remake from the control stick, are these machined aluminum blocks. Now, this is 6061 aluminum that I machined on a milling machine, 3/4 of an inch hole. These are not quite finished yet. These holes at the moment are just really small through holes, but they're going to get tapped and threaded for 440 brass screws. And then, just like on the control stick, I have some metal, it's some thin stainless plate that will go over top of here, and those little screws will attach that plate to these. So what will happen is, just like on the torque tube for the control stick, these get slid on, just like so. And then that plate then will prevent the tube from coming through, obviously. So it will be roughly like that with the plate. So there'll be a plate on each end, which will, in effect, capture the tube so it can't move around. And then, of course, these get bolted right through the uprights on the fuselage. So that is the way that I'm doing it. This is actual flight hardware so far. knock on wood, so to speak. I haven't screwed it up enough yet to render it non-flight worthy, so this is an actual flight hardware piece. From here, I'm going to incorporate another, nothing this beefy, just a flat plate over on one side for my elevator trim springs to connect to. And then after I'm happy with that, that will get welded on. This will get welded all the way around on both sides. And then, well, the whole thing will be sandblasted, and then I'll do my welding, then I'll come back and sandblast it again and do the painting. So there you have it. So far, so good. Here is the bell crank welded and sandblasted. On the far end down here, this is my lever for the trim system that I'm going to be installing. Again, you can see the fork for the rod end to go into, and then this is the trim lever here, and I put multiple holes in it so that I can make adjustments if I need to the feel of the trim. Now, if you can imagine this in the airplane, and if the front of the airplane is to the left, this would mount like this. And since I'm using the push-pull tube, and right now the attachment of that push-pull tube to the pilot control stick, that's in the stock location. So when you push the stick forward, it's going to pull the rod end at the bottom forward as well. And then that will translate to a down elevator in the back. And then you can see that obviously the lever for the trim works in the same direction. So in theory, I haven't decided yet, but I'm planning on having a trim lever in the cockpit. So if you need nose down trim, you push the lever forward, which will pull this lever forward, which again will translate to down elevator. So there it is. That's that. I'm going to take some pictures, and I'll take some pictures of the welds. I'm very pleased with the welding so far. Everything has turned out really nice, in my opinion. So let me do that.